Okay, good night or good morning. I think we're in the wee hours of the morning here. Just truly Professor Dr. Dolphy Gilpin here, and we're continuing with our grounded periodic table, not too visible from the camera, but we'll try to show you to you afterward. And we are in the process here of getting 3D projection of NASA and NASA facilities, illuminated 3D projections. And since we have done NASA so many times already, like NASA JPL, NASA Kennedy Air, Kennedy Space Center, and now we're going to do NASA Johnson Space Center. That is JSC. So the base remain constant, NASA, and we have used all the relevant elements of the periodic table to spell with the N. Like for N, we'd use nitrogen, and other N, sodium with a dominant N and a recessive A, and so on. For S, we'd use like for sulfur and silicon and aluminum and other elements. So NASA. Now we have JSC, and we have come to find out that the letter J is not represented on the periodic table. Neither in a dominant or in a recessive fashion. And this is to say, oh, the letter J has no chemical validation on a periodic table of 118 elements. I find it a bit not too logical that such a letter as J would not come to find a place on the periodic table. We have very important places like Japan, Jamaica, Jerusalem, a lot of places that some scientists, somewhere or the other, can make some discovery and let the letter J come into the periodic table. But that's for another reasoning. We're on JSC here now, Johnson Space Center, and here we have the J, S, and C. And like I said, J is not represented on the periodic table, but S is represented by sulfur, aluminum, and let me show you what the S is. Other S, scrotanum, zirconium, letter S, in some fashion or the other. Sulfur, dominant S alone, aluminum, dominant S recessive E, scrotanum S, dominant S recessive R, and look at the other S's too. Let me see if I see any other S here. So far, that's the only S's I've seen. All right, silicon, that's a very popular semiconductor. Scrotanum, aluminum, samarium, and scandium. And so the S is going to represent those elements. And JSC, and C is going to represent now carbon, curium, chlorine with a dominant S, C, and a recessive L, carbon standalone with a dominant C, and curium, Cm, and cerium, Ce, dominant C, recessive E, calcium, very important element, dominant C and recessive A. And so far, that is what I've seen with the C's. Let's look at the C's here. So that's going to represent our, we're just focusing on the top here, projection, because the bottom we spell NASA going around this quad here. It's constant. And so all we'll be changing is the top to represent JSC, JPL, Langley Research Center, Ames Research Center, NASA Goddard, and so on. And we'll be spelling them, exercising our chemistry. And this could be some project for high school or even junior high school people. Everybody's photo sort of photopic, magnetized to light. And these help us to study our periodic table and have it tangible. So here we have those JSC, Johnson Space Center. As you see here, represented the carbon and calcium and copper. That's another one. Copper, Cu, dominant C and recessive U, with atomic number 29 and atomic mass of 63.546. Calcium, Ca, chromium, atomic number 24, and atomic mass of 56 or 51.992. Calcium, atomic mass of 20, and atomic number 40.78. Curium, atomic number 96, and atomic mass of 207. And californium, that's another C, CF, atomic number 98, and atomic mass of 251. So those are the C's, and of course carbon. And there's another C over here. What is that? Cl? Oh yes, that's chlorine. Yeah. And there's another one, cadmium, Cd, cadmium, dominant C and recessive D. So here we have it for JSC, NASA JSC. Johnson Space Center is another facility of NASA. And so we're going to put it on the top here and get a 3D illuminated projection of NASA JSC. So we'll return once more with another confirmation. And this is just an introduction. We'll expand on it at another time.